Chapter 7.6, we're looking still at exponential functions. Specifically, today we're going to be looking at growth and decay problems. So we're solving problems involving exponential growth and exponential decay. So a couple of formulas, three formulas actually, that we'll look at that you'll want to probably have copied down somewhere at some point. Hopefully we'll do enough of these that either you'll see the pattern and you can duplicate it without seeing the formula, or you just copy until you kind of get it stuck into your gray matter. So here's the first equation. It's the equation for exponential growth, and I've got it written down here at the bottom. It's a little bit easier. Y equals a open parentheses 1 plus r close parentheses raised to the t power. Okay, so there's your formula. Here's what all of the things mean, okay? So A is going to be our initial amount. So it's going to be the amount of whatever it is that we're doing. It's the amount that we start with, the initial amount, okay? R is going to be the rate of change. Now, rate of change is going to have to be expressed as the decimal. A lot of times these rate of changes come to us in the form of a percent. And so we don't do calculations with a percent. We convert it to decimal form, and then we do the calculations with the decimal form of the rate of change. Okay, T, we're raising to the power T, and T is going to stand for time. So how long are we going to have something exponentially grow, or in just a few minutes have something exponentially decay? And then Y is our final amount. Right, so if A is what we start with, and then we do all of this exponential growth to it, Y is the final amount. It's what we end up with. Okay, so those are the 4 or 5 pieces. Those are the 4 pieces that we might have as an unknown, and as long as only one of those pieces is unknown, then we should be able to plug into this formula and algebraically manipulate to figure out what our missing piece is. Okay, so here's our first problem. And I've got the formula up here just for reference. Okay, so if you need the formula, there it is. Again, at some point that'll want to be committed to memory, but here we go. The contest for the prize for a radio station contest begins with a $100 gift card. So if I'm thinking to myself exponential growth, I'm already kind of picking out some of the pieces that I need. And if you'll remember, A is the initial amount. So if a contest begins with a $100 gift card, then that might be my initial amount, the 100. Okay. Once a day, a name is announced, and the person has 15 minutes to call, or the prize increases by 2.5%. So that 2.5% sounds like a rate, and we're going to go ahead and express it as a decimal. So remember, from a percent to a decimal, we move the decimal place 2 times. So 0.025 is our decimal rate. And then the increase is by 2.5% for the next day. So that tells me how long of a time period I'm talking about. So once a day, and then for the next day, that's telling me the length of my T. Okay, so don't get confused with the person has 15 minutes to call. Like, that 15 minutes is not how things are growing. The thing that tells us how it's growing is the next day. Once a day, a name is announced, the prize increases the next day. So here we go. We've got those pieces kind of identified. I'm gonna let this go away. And then what's our question, right? We don't have a question yet. So here we go. Part A. Write an equation to represent the amount of gift card in dollars after, okay, so this sounds like a final amount if it's after T days with no winners. So here we go. My final amount is my initial amount times 1 plus, that's not a 1, sorry about that. 1, oh, still, where'd my, there we go. 1 plus my rate And then after t days, so they didn't tell me a time, so we've still got a t up there. Okay, so take a second, take it all in. We identified our original amount. We identified our rate. And then the time we don't know yet, right? Because after t days, so we don't know our time yet. And we don't know our final amount yet. Okay, so this is the equation that represents the final amount of the gift card after 10 days. Okay, now thinking about order of operations, thinking about I have to do things in a certain order. Okay, kind of be thinking through that. So here's part B to the question. How much will the gift card be? What will the final value be? How much will the gift card be worth if no one wins after 10 days? So now they're telling me that t equals 10, and so we can substitute that in. And so they're asking, what is y if my initial amount was 100, my rate was 2.5%, and my time is 10 days. Okay, what will the card be worth? Now, I'm going to give you a second to plug this into a calculator. This is one of those times when you're just about going to have a calculator to do these problems. I'm going to give you a second to plug this in, and you tell me what the gift card will be worth. Okay, keep in mind that we're talking about money, so make sure you round appropriately. All right, so that gift card should be worth, after 10 days, $128.01. Okay, now if you're not getting $128.01, we'll talk about making sure you can get it plugged into your calculator appropriately. As long as you've got these numbers, right, we should be able to get to this answer using your calculator. All right, so here's your next equation. Okay, exponential decay. Now this formula ought to look a lot like the exponential growth formula. The only thing different would be the minus, because growth means we're adding and decay means we're subtracting. So now we're subtracting, we're decaying. So A is still going to be our initial amount. T is still going to be our time. R is still going to be our rate as a decimal. And our final amount is still going to be the Y, the what happens after we do all of this. Okay, so here's your problem. Again, reading through this scenario, picking out an initial amount, a rate, and what length of time are we talking about. So a fully inflated child's raft for a pool is losing 6.6% of its air every day. So we've got a rate there, and as a decimal, 0.066. The raft originally contained, that sounds like a starting point, 4,500 cubic inches of air. Okay, and then every day, so it sounds like our time is going to again be in days. We don't know the value, but we do see that time is going to be in days. So our question then is, A, write an equation to represent the loss of air. Okay, so here we go. Our final amount is going to equal our original amount times 1 minus the decimal rate raised to the amount of time, which we don't know, so we're going to stick the t back up there. Okay, and there's your equation that represents the loss of air. Estimate the amount of air in the raft after 7 days. In other words, 7 days has passed. We've been losing air all this time. What is my final amount? Okay, so hopefully, right, the only thing that changes from that original equation up there is that now I know my t is not t anymore. Now my t is 7. So you evaluate this, approximate it. So if we're approximating, like, it would be okay just to go to the nearest whole unit. Okay, you should get our final amount is approximately 2,790, and we're talking about cubic inches, so we'd probably want to know that we're talking about cubic inches. No, that's not something I would count off on, but let's not lose track of the context that we're working in. Okay, so again, being able to identify the pieces that go into the formula and then evaluating, doing the math, right? So there's one more formula. Here we go. This one's going to be a little different. A few more pieces, but we're talking about compound interest. We're talking about money that's growing, okay? And specifically, we're talking about compound interest. You'll notice we've added a couple of pieces here, and we've added a piece here. So let's make sure we know what all of those pieces stand for, okay? So let's start off with P. P is the principal amount, okay? So give you a little background. Principal is there it is. Principal is the initial amount or the initial investment, okay? So principal is what we start with, okay? R is still going to be a rate. Specifically, it's going to be the interest rate. And we're going to express that interest rate as a decimal again. So no percents here. Like we've got to take that percent and turn it into a decimal. Okay. T is still going to represent time. This time T is going to be specifically time in years. And N, that shows up in a couple of different places here, N is the number of times interest is compounded each year. In other words, how many times each year are we going to add interest? Okay, so the number of times the interest is being compounded, the number of times the interest is being added each year. And then T is time in years. And then the amount that we would end up with, our final amount there, is still going to be our A. So grab that formula. Make sure you know kind of what all the pieces mean. Let's look at an example, okay? Maria's parents invested $14,000. Now that's an investment. That's a principal amount. So there's our $14,000, okay? At 6% compounded monthly. At 6% compounded monthly. So if we're compounding monthly, if we're compounding once a month, in a year, how many times would we add interest? 12 times, okay? So our formula says we're going to do 1 plus, and then we've got our rate expressed as a decimal, so 0.06, divided by N was the number of times we're compounding, so we're compounding it monthly, so that's going to be 12 times in a year. And our exponent here is going to be N times T. So again, N is how many times we're compounding. 12. That's not a 12. That's a 12. Compounding monthly 12 times. And then T is how many years. And in this case, we're looking at 10 years. Okay? So we've got to be able to pick out where all those numbers come from. Okay, you got to be able to pick out where all those numbers come from. But once you get it plugged in, like it should just be a matter of you evaluating. So I've got everything plugged in. We're going to practice plugging some in tomorrow. But for now, let's see if you can run this through your calculator and see what your current amount is on the other side. So you evaluate this expression and tell me what you get on the other side. Keep in mind it's money. So we're going to round to the nearest cent, okay, or round to the nearest dollar, but you figure out what that looks like and type it into the box, okay? Should have gotten, and I'm going to give you decimals, right? So should have gotten $25,471.55.